My name's Russell Fair. I am from Atlanta originally, but I now live in Boise, Idaho, where it's much cooler and far less humid than here. So I had this really nice outfit I was going to wear today, and then I decided not to. This presentation I've given a couple times at some coding boot camps, which are kind of like the Iron Yard that we were talking about last night. Very similar concept. People come in, they do an immersion type of study, learn a whole bunch of code, and then they get churned out into the real world where they realize that, in fact, it may be a lot different than what they learned. And so I do these talks to try to help them understand some of the trends that are happening in the professional development space right now. This talk is not necessarily WordPress centric. I'm going to do my best to make it somewhat WordPress-y, but this is really relevant for any programming, any software development, web, mobile, whatever it is you're doing. And I like to start out every presentation that I do with this quote, which is that a candle loses nothing by lighting another candle. You asked me earlier maybe why I was here. Do I get business from this? Is this, what's my motivation for doing this? And while there is always the concept of I could meet someone here that could become my next $1 million client, really this is about me trying to pay forward some of the things that I've learned in some of these situations. I was at a code camp in Atlanta probably in maybe 2011, and I heard a man give a very similar talk about coding katas and about test-driven development. And when I heard it, I had never done any TDD, and I went home and I tried it, and I was hooked. And then after 5 years of playing around with it, I realized how little I actually knew about it and that I didn't know what I was doing. So then I actually learned how to do it the right way, and my eyes were open to this whole new realm of possibility when it comes to doing software development. So that talk really stuck with me. I've taken a lot of what I learned in that presentation and have implemented that not only in my own practices, but in the classes that I teach and the people that I mentor. And I just see this as such a valuable tool that I want to help other people embrace these tools and learn about them. So one of the thoughts here is, how do you become a great musician? Anybody? Practice, right? There's no way that I could hand you a cello right now and say, play this piece by Mozart. You can't do it. There's no way you can do it, right? I can't hand you a trombone and ask you to play even a basic scale. If you've never done it before, you're never going to be able to accomplish it. You have to fail a lot and do it over and over and over again in order to get good at it, right? The other analogy is like, how do you hit a 90-mile-an-hour fastball, right? I can't take my 11, almost 12-year-old son and take him and put him up against here's my Atlanta coming out, up against a John Smoltz fastball. Even a John Smoltz fastball today, there's no way he could hit it. You have to swing that bat so many times before you develop the technique to connect with that ball, right? And so in these industries, the expectation is that you're going to practice and you're going to go through the motions enough times that then you can become a professional. Interestingly enough, the software development industry seems to be completely different. For some reason, we think that we can take people straight out of college, or not even college, but out of an 8-week immersion boot camp and throw them into the wild, that we can put them into the orchestra pit, or that we can put them at the plate against an MLB pitcher, and that they're going to be able to hit a home run. They're going to be able to actually get the work done. It's just not really practical, right? We need a way to practice what we're doing before we're doing it professionally in a setting where we're expected to do it right? In software, we learn on the job for some reason. People just go into this realm, they don't really know what they're doing, and they just kind of figure it out as they work. And for most people, that's an okay way to do things. The purpose of coding katas, however, is to give you a framework for how to do that, right? For how to actually learn how to write software. So I'm not going to put you guys through this entire video because it's a little bit long. Can you hear it? Oh, there's no light. It's coming through my computer. It's my computer, it's not pumping it out. No worries. I'll skip ahead a little bit. All right, so just to kind of put that clip in context a little bit. So this is from the Karate Kid, obviously, and the first time I gave this presentation, none of the kids in the room had ever seen this movie. So I dated myself just a little bit there. But the whole context of this was that Daniel-san had gone to Miyagi and asked him to teach him martial arts, right? And Miyagi spent the first 2 weeks making him do manual labor. He made him wax the floor, paint the fence, all the stuff, right? But what he was really teaching him was the martial arts. Daniel-san didn't realize it, right? At the end, there's a good movie, I forget what it's called, but there's a line in that movie where he says, "Oh, you Miyagi'd me," right? Does anyone know what movie that is? It's like Steve Carell or something like that. He's like, "You Miyagi'd me," right? You taught me something without me realizing that you're teaching me that thing, okay? And so basically what this comes down to is if you think back to that baseball analogy, right? Or that cello playing analogy, it's in order to do this well, you have to have muscle memory, you have to have speed, you have to have confidence, you have to have a lot of technical practice in doing it. And so what a coding kata is basically just a thing that you can do that you're not going to necessarily ever use it. It's not going to be an app that you're going to make and release or launch or sell or anything like that. It's literally just a development exercise that you can do so that you can practice writing software. It's a way to develop muscle memory. It's a way to develop the speed, to have that repetition, right? To literally just get the reps in. The other cool thing about coding katas is that it allows for you to separate the critical thinking components from learning a syntax, right? What language did you guys study at the development guild?
Oh, you mean under class?
Mm-hmm.
Oh,
Didn't you say you went to Senkos?
No.
Oh, you did? Okay. Well, my bad.
I'm
Okay.
learning JavaScript right now.
So you're learning JavaScript. Perfect. So if I said I want to teach you Ruby, you would be learning a completely new language, right? Or if you said, hey, I want to get good at WordPress, you're going to need to learn PHP. It's a completely new syntax, a completely new language. If you also say, hey, at the same time, I'm going to learn how to build a plugin or make a website or create a custom theme. Now you're doing two things at one time. You're doing the critical thinking that's required for how do you build a plugin. You're also learning a language, right? And so when you're trying to do both of those things at one time, the difficulty is much harder because you have to do the problem solving and learning the syntax. With coding katas, you're doing an exercise that is relatively simple, and you've probably already done it a few times. And so then you can separate the critical thinking from learning the syntax. It allows you to focus only on learning the syntax, right? So the example that I like to give is a simple 4-function calculator. Okay, if I said, hey, build a calculator, a 4-function calculator, what would you have to have? Keep going.
Multiplication, division.
Yeah, you'd have to have the 4 basic math functions, right? You already pretty much know in your mind, just with what I've told you, like what it would take, what would have to happen for a calculator to be successful, right? So now, with that in mind, all you have to do is learn, how do I learn enough PHP or enough Ruby or enough JavaScript or whatever language I want to learn so that I can implement this basic 4-function calculator, right? So the idea is that if you've already solved the problem with one language set, by separating those 2 responsibilities, you're able to learn a new language much faster. Okay? So that's kind of the gist of a coding kata. And usually there's probably 10 or 15 katas that I put my students through. Usually the first pass through is much more difficult. We usually do it in something really easy to use, like Scratch, which is a drag and drop framework that doesn't require any typing. And then once they've done it in Scratch, we go through all of the exact same exercises again in Java, which is an object-oriented, or Python in a non-object-oriented way, right? So that's kind of the idea is you've done it once before in Little League. Now you're going to go do the exact same thing. You're just going to do it in another language. So you've got to master that syntax, figure out where all the curly braces go and what the @ symbol means and how to declare a variable and all that. But then you're off to the races. I've already kind of touched on this a little bit, but the idea is that it creates muscle memory not only for your fingers, physically, like how do I reach the greater than and less than symbols on my keyboard, and where is that curly brace that I need, right? It's that muscle memory, but it's also muscle memory for your brain. Like I've declared enough functions already that when I'm going to actually do my professional work, I don't have to think about how do I declare a public function or a private function. I already know how to do that. I've done it enough in my katas that it's just second nature to you, so it comes much quicker. So this is another good quote. It says, it's often true that whether a person carries with him an atmosphere of gloom and depression or one of confidence and courage depends on his individual outlook. And so I like to bring this up because coding katas are a way to give you confidence. Right? If you can go through a set of katas very quickly and feel confident in what you're doing, you can go into the professional workplace much more confidently, and that confidence is going to have a huge impact on your ability to produce, right? It's going to give you a better attitude, it's going to help you see through problems differently. It just changes the trajectory versus someone who is going in without confidence and really feels intimidated by what they're about to do. So that's a little bit about katas. Any questions on the coding kata concept before we jump into TDD? No? So test-driven development, or TDD, it's not new. People have been doing test-driven development for a long time. By long, I mean long in terms of like relative to the internet. It's been going on for a long time. It's not something, however, that a lot of developers start out doing. They generally start out doing what I call a refresh-driven development, which is where you make something, you type it up, you reload your browser, and then you see what happens, right? Or if you're working in something that's not a web-based product, like maybe you're doing something in Python, you're going to just run the program and see what happens. And if there's like a syntax error, then you just gotta go find it, right? But you're building it and then you're testing it in your mind. Did it do the thing that I expected it to do, right? So there's a margin of error inside of that computer to your mind transfer that has to happen. And test-driven development allows for you to actually build code to test your application code. So think of it like this. If I was building a plugin, I would have all of my code that is my plugin. I would also have a whole bunch of other code that just test the code that makes my plugin. Does that make sense so far?
Say that one more time.
So I would have like two sides of my code. I would have a bunch of code that tests the plugin application code, and then I would have the actual code that makes the plugin thing, right? So, and I'll give an example of that in a minute, but basically, like, so my calculator example, right? And maybe I have a slide in here for this down the road. If I was gonna write a calculator, what would probably be the first function I would write? I would write add first, right? Because I know that a number plus a number should give me what I need. Like, that's a simple function, I would start there. Before, the idea of test-driven development is before I write the application code, I would actually write a set of tests, or at least a test, to test my add function, right? So I might have a test that says, test that 5 plus 5 equals 10. And I would run that test, and my test would fail because I haven't even started my calculator function, right? So the idea is that you go through this process they call red, green, refactor. Red means you start by writing a failing test. Then you write application code to the minimum amount of code necessary to satisfy that test, right? Take a test that fails, make it pass. Then refactor your code however necessary to like clean it up, simplify it, you know, make it a little bit prettier, whatever you need to do. But as long as that test continues to pass, then you're good, right? So as you work through a challenge, right? So then I might have another test that would then say test that 10 minus 5 equals 5. And I would write that test and it would fail because I don't have a subtract method. So then I would go back and I would write my subtract method to satisfy that test, and then I can move on, right? So you're constantly in this mode of first writing a test, then writing the minimum amount of application code necessary to satisfy that test, okay? There's a lot of benefits to doing this. So first of all, I'm just gonna address the elephant in the room. It takes a lot longer to write code using TDD, okay? I usually tell people that it takes 3 times longer to write TDD-based code than it does to write non-test code, okay? So a lot of people give me pushback. They're like, oh my gosh, does that mean that our bill is gonna be 3 times as much? And I say, yes, absolutely. You're gonna pay me 3 times more than this other person to write this code for you. And they say, well, why would we do that? It's like, because mine will not break, ever. Because I've written enough tests that I know that it works. So long term, you will end up spending a lot less with me because you're not having to hire me to come back and fix things and do bug fixes and handle this. Now, I'm not saying that test-driven development generates perfect code, because it doesn't. Has anybody caught the reference on my hat yet?
TDD.
Uh-huh.
Built-in.
Read it one more time.
Read it out loud to me.
I can't. Yeah, I can't.
Quality is
spell
built in, TDD quality
It's
is built
close. Quality is actually misspelled. It says quality
Oh,
is
okay,
built in,
yeah,
right?
okay.
So it's a good analogy in the sense that if you write crappy tests, you're still going to have crappy code, right? So doing this does not mean that you get a perfect 100% bug-free application all of the time. It does, however, mean that you're a lot less likely to have bugs because your code is cleaner, well thought out, and tested. It also reduces the cost of changes to that application code down the road, right? So if you say, hey, you built this 4-function calculator for me 2 years ago, now I need to turn it into a scientific calculator. I needed to do tangents and sine and cosine and, you know, all of that. And I've got to go back and do version 2. I'm a lot less likely to break something from version 1 because I've got all those tests, right? And I can actually satisfy that, hey, this thing works by handing you a copy of all of the tests that I've run and those tests being passing, right? The other benefit is that it forces you to understand the acceptance criteria of what you're doing before you build it, right? You have to know exactly what you want the thing to do before you build it, because you can't write a test for it if you don't know what you want it to do. So it actually allows for you to have the acceptance criteria inside of your code base. So if somebody says to you, what does this software do? I can print, not that I would really print it, but I could like give you all of the tests. And I could say, it does all of these things. This is all that it does. It doesn't do anything that is not in these tests. Right? So it allows me to know exactly what my application does and does not do. If someone comes to me and they say, hey, this thing doesn't do what we expected it to do, I would say that's because there's not a test for it. If you want that, help me write a test. And then I will go make that test pass and it will do what you want it to do. Right? It also allows you to really focus on what you're doing. Instead of saying like, I have to build the whole plugin, and going, oh my gosh, well like, what about this thing? I gotta think about this, I've gotta think about all these pieces and I gotta put it all together just right. I don't have to think about all of it. I only have to think about the part that the test that's failing. I only have to think about the one thing that I'm working on right now. And so it allows me to not see the big picture so much and really get granular with what I'm doing. So that's helpful. Another benefit of TDD is interfaces. And this is a little bit more complicated of a concept to understand, but because you're building code that has to be it has to be able to talk to the testing framework, or at least the testing framework has to be able to talk to your application code, it forces you to build your code in a way that has controllable interfaces that are that generally yields much better software, right? So things like public versus private methods and public attributes in a class, for example, are all things that you test against, and so it makes you write code that is a lot easier to interface with. It definitely yields prettier looking code. I'm sure you've seen this before. Have you ever taken a look under the hood of somebody's like template or a plugin that they wrote, and it's just this gnarly mess of crud? I have.
Yes.
I look at that crap all the time.
I start crying.
Okay, yeah, I just start deleting. I don't even look at it. I'm just like, nope, delete, not taking it, right? When you're doing test-driven development, it generally yields very short, very small functions. I'll show you a couple examples of some plugins that I've written using TDD before, and most of my methods have one line of code in it, right? So it's a function with one line of code. That's all that function does. By doing so, it means that code is much easier to reuse and much less error prone, right? And so that's another benefit here. And then dependency management is another benefit. So if I have a dependency in my code, it's a lot harder to test that dependency. So it allows me to really separate my dependencies from what I'm building so that I'm not baking in all of these weird dependencies and things that I can't necessarily test. I don't know if this is the last one of the benefits. There's a whole bunch of reasons why you would do TDD, but another one is that it's a lot easier to refactor your code, right? How many times have you inherited something, or not even inherited something, like you worked on it in 2018, your client calls you and says, hey, we really like this, we want you to add some stuff to it, and I look at it and I go, I don't even remember what I did for you guys. Like, who are you again? Oh, that thing. Yeah, not sure if I'm going to be able to do that or not, right? If I have enough tests behind it, then I'm confident that I can take what I've worked on, add something, remove something, change it up somehow, and then rerun all my tests and know that I haven't broken anything. It gives me confidence. So there's a whole benefit of having tests, especially if you pick up code down the road. I mentioned fewer bugs. Again, I didn't say no bugs. I said fewer bugs, right? If you write bad tests, you're going to have more bugs. But if you have good test coverage, you're going to have less, for sure. Yeah, go ahead.
I have a question.
Yeah.
This testing that you're talking about, are you getting it from the client or getting it from somebody who's the code at the end? Or like, are you making it based on what they tell you?
Yeah, so generally what happens, there's two ways to do it. I can either work with the client, if they have developers in-house, they can write the test. It's really hard to do it that way. or I will sit down with them and get a sense for what they want and write tests as part of the process of what we're doing, right? I could take a feature ticket or a feature request, and I could actually look at that and think, okay, this is what they want. Let me write some tests first to encapsulate what they want the software to do, and then I work on the application code. So usually I write the test. Does that answer that? Increasing returns. So I mentioned that sometimes it takes 2 to 3 times longer to write test-driven code, and so the way I typically present it is that the costs are front-loaded. If you look at the overall cost of an application, usually the smallest cost of it is writing the actual application. The majority of the cost is in support and fixing bugs down the road. So by doing this, you're basically front-loading some cost, but the overall cost throughout the life cycle of that application is actually far less. So over time, you start to realize and appreciate those returns, right? Especially when new features come in. We need to refactor something. Oh, well, this test broke, so that refactor still needs work. I can't accept this until all of the tests pass. Okay? And then hopefully this is the last one. Again, I mentioned living documentation. All of my tests are in the code, so I know exactly what my application does. I know what it doesn't do. If there's not a test for it, it doesn't do it. Right? So I gave you a little bit about the why you might want to do test-driven development, and I've talked briefly on what it is. But basically, this is the concept, right? You write the code to test the feature before you write the feature. So you go from that red, green mode, right? You write a test that fails, then you write the application code to satisfy it. And then the last piece is the refactoring. I don't always do that, but a lot of times I'll write something and I'll go, okay, yes, my test passed, but this could still be better. Like, let me refactor this and still make it better. And as long as I don't break the test or any of the other tests, I just move on. Okay, so I'm going to try a demo. I've started this demo last night, and I thought I would have it working by now, and it's kind of working. I'm going to try it in PHP, so it's WordPressy. And if it fails, I'm just going to switch to Ruby, because I have a demo in Ruby that I know works. Okay? In fact, I might give you a little bit of both. How are we doing on time?
Yeah, you're good.
You got plenty of time? Okay. So I might try it in both. So let's jump into PHP Storm. Let's set up some bigger font. Can you guys read this?
Yeah.
In the back, can you read it? Okay. All right, let's do a little bit bigger. Can you read that?
Yeah.
Yeah.
Okay. Perfect. So let's see here. So this is just basically a very basic set of tests. Let me find it. So just a couple quick tests, right? So this first one on line 11 is just literally hello world in the testing world. I'm just testing that true is true, right? True is always true. So I'm basically just telling my testing framework, assert true, right? I'm telling it, these two things, this is true, and that test will always pass. So if I just had that test, I would have one working test, and that would be about it, right? This whole concept of these tests is that you make assertions, right? You're telling the code to expect something, right? You're informing it of what to anticipate the software doing, right? So I've got a couple of just basic tests here. This says like assert that the file exists, and then it actually checks the name of the file, right? So it's a pretty basic test. It's just saying, hey, the file is in the right place. And then I'm testing a couple other things like if I look at, like, does this directory exist? Does this file exist? Is this file an instance of a specific class? That sort of stuff, right? So right now I have basically this plugin doesn't do anything. So I'm gonna just run these tests really quick. And you'll see here, so I just ran this test, and it tells me down here in green, you can't read this, but I can, it says 4 tests, 8 assertions. So right now everything is green, okay? If I wanted my application to, for example, be a calculator, right? And I'll use that analogy because we've already worked through some of the challenges of that. I would first need to test it, right? So I am going to I'm going to start with that 5 plus 5, right? Now remember, my plugin right now it's not a calculator. It has no adding capability at all. So if I run this, if I say, I'm not even ready to do that. Let's do it this way. Okay, so I just wrote a test, and let me just walk you through this, right? I'm basically saying, instantiate this object, and then call the add method to that object. And past 5 and 5, expect 10. Okay? So if I run this, it should fail for a myriad of reasons. And I'm just going to run it just even though I know it's failing. Right? And it's basically telling me there's an error, so I have, instead of having a green, all green now, I have red. I have a failing test, which is what I want. And it tells me that I am calling an undefined method. First of all, because this is not a thing. Okay, so it's telling me that there's an undefined method, add. Okay, which is exactly what I expect. I have not written an add method yet. So how could it possibly work? So I've got a test that fails. So now I need to go from red to green. So I'm going to come over to my plugin code, right? And I'm actually going to a method called add. Okay? So now I have an add function and it doesn't do anything. Okay? I can cheat and I can just make it return 10. And now when I run my test, instead of getting red, I get green. Yay, I have an add function. Okay? Problem is, my add function doesn't work because it always returns 10. So if I come over to my test again, and I just basically copy this little function, and I would say, let's try adding 7 and 7. Right? 7 and 7 should give me 14. And so I need to change my test here, right? I'm adding 7 and 7, and it equals 14, right? So this test should also fail. And what's nice about this is it tells me, okay, there's one failure, and it says failed to assert that 10 matches expected 14, right? I want 14, you gave me 10. The thing doesn't work. So now I'm back to, I've got a method that, I've got a failing test, I'm going to go back and refactor. And really what I have to do here is make this function do something other than just return 10 always, right? So what I'm going to do instead is I'm going to just tell it to return the sum of those numbers. And now when I run it again, with any luck, I'm back to green, right? So now I have a part of a calculator here working. I've got an add method, right? So now what would be the next test that I would write in my calculator?
Add 10 plus 10.
Okay, I could do that, right?
It's testing out.
Yeah, I mean, I could sit here and keep doing this. What's actually would be better would be if I just have all of these in one big function, right? One test with multiple assertions. So I can refactor this and I can say, okay, if you want me to add 10 and 10, I'm going to give you 10 and 10. And I'm going to rerun that and see if it works. Still works. My calculator works. I could do this ad nauseum. I know adding now works. Now maybe I want to try negative numbers. All right, let's do that. So let's do, I want to get -5 when I add 5 and -10, right? So if 5 plus -10 should equal -5, right? Check my math. If I mess this up, you have to stop me because I will mess it up eventually, and I've kind of like freaked out because I don't know what's going on. Let's see if adding negative integers works. Okay, that still worked. So what about the other way around, right? I want to get 5 when I add -5 plus 10, right? -5 plus 10 should take me to the other end of it, and I should get 5. Okay, I'm good. My add function is definitely doing what I expect it to do. I pass it these numbers, and it works. Okay, I've got add covered. What's my next function? What am I going to work on next?
Subtraction.
Subtraction. Okay, so we'll just call this, we'll call this test subtract. Okay. And I'm going to do the same thing. Basically, I'm going to instantiate the method or the object, but instead of doing calculator subtract or calculator add, I'm going to do calculator subtract, right? So calculator subtract. And if I tell the calculator start with 10, subtract 5, I should get 5, right? 10 minus 5 is 5. So when I run this, with any luck, I have a failing test again. Yep. It says call the undefined method. Again, I don't have a subtract method. I haven't written it yet. So I have to go back and add that. Now I could come back into my application code and write it. You can also cheat, which I recommend. Cheating is good in this industry. Okay, don't confuse that with doing something unethical, but I'm gonna let my IDE do the work for me. So rather than go through and type out this, I can just come into my IDE. You can't see this, but over here, this is PHP Storm, by the way. Most IDEs will do this for you. It'll actually say add method, right? So if I hit that, enter, it just created a function for me called subtract. Now it's doing some weird things from a coding standards perspective because my IDE is not configured to use WordPress's coding standards. But, that's another talk for another day, right? So I have a subtract function, and I know basically what I want it to do, right? I want it to return integer 1 minus integer 2, yes? So let's run it again and let's see how we're doing. Okay, I messed up. I assumed it was going to give me integer 1 and integer 2. It didn't. I don't really like that, so I'm going to fix this the way that generated automatically. I'll run it again. Still red. And the reason is because my method is private. Okay? The IDE added it as a private function automatically. Now, this is a little bit more advanced subject when you're dealing with public and private methods. If you want a method to remain private, then you have to have a reflector class to basically turn that method public without actually changing it. That's another story. Not one that I want to get into right now, for sure. The other thing that's happened is this created, my IDE created this in the wrong place. That's another part of the problem. So I'm just going to move that really quick and put it into the right place and run it, and now it passes. Okay, so now I've got a subtract function, and similar to, I realize I'm talking to my computer and not you guys, I'm sorry about that. Similar to how I wrote the test for the add, where we went through a handful of cases, I might do the same thing for the subtraction bit. Right? So on my test, I might come up with a couple examples. I might say that 5 minus 5 should equal 0, negative 5 if I give it 5 and 10, and 5 if I give it negative 5 and all right? Okay, see, I told you I wasn't going to get this math right. So if I have negative 5 and I subtract negative 10, it's the same thing as adding 10. So I should get 5 when I run this. So let's see what happens. Fingers crossed.
I think that's 15.
Test pass. I'm good with it. I can live with it. Now, what if you come up and you say, hey, what about floating point numbers? Right? What if I say I want to get 5 if you give me 7.5 minus 2.5? See what happens. It still worked. Okay, cool. I just refactored it. I made sure it supported non-integer numbers. I'm good here, right? And I could do this again for division, multiplication, right? If somebody came up and said, hey, I really want you to also do, the example I got from the other one that gave me a hard time was derivatives. I asked him for another type of function that I could add to my calculator. And he said, well, make it do derivatives. And I said, what's a derivative? And he explained to me that it's like the number, I don't even remember, it's like that number to the power of, it's the power of the number minus 1 or something like that. And so I had to figure out how to make a method that would actually yield a derivative. But I did. I figured out how to make it work. So I could now go through here and I could build my whole calculator out, right? I could have multiplication, division, derivatives, square roots, whatever it is that I want to do. And every time I run it, as long as on my test pass, I know I haven't broken anything. I know I'm good. Okay? So that's kind of it in a nutshell in terms of how the test-driven approach works. Do you see the whole make a test that fails, get to the point where it's red, and then go back and change it to where you're green? If you notice the way that this code looks, first of all, let me just point out that my test, I have from 46 to 60, so I have roughly 13 lines of code to test the application. And the application itself is only 2 lines, real lines of code. This is a pretty simple example, obviously. If we were talking about something more complex, then the complexity would be up. But I had to write 10 lines of code or more to make something that has 2 or 3. Right? So yes, it takes longer, but confidence, I know this will never break. Right? Again, these are pretty simple components. And then, yeah, I do need to refactor this, right? So here I used int1 and int2. Above I used in. So I might just kind of come back and do a little refactoring, double check that this is good. I don't know why these parentheses got in the way here, so I'm gonna do that. Just gonna run my test one more time, make sure I didn't break anything. Yeah, that refactor is good. Like, this is shippable. I would commit this and I would move on.
How often do you run a test? I mean, every time you change something in the code, or just every time you change a specific function?
Every time I think that I
Might
got
have screwed it
right,
up?
right? No, I literally,
Oh, okay.
I run now. So I didn't set this up correctly. Let me just jump over to Ruby really quick, because I've got my IDE set up differently. So the benefit of using an IDE is that you can run all your tests right here. So I generally run the test. Well, first I run it when I know it's going to fail, just to make sure it fails, to make sure my test is being run. And then I run it again when I think that it might pass. So sometimes I only have to run it once to go back to green, and then refactor, run it again, and then ship it. Now I'm going to get into this in a second. Let me just see if I can get this TDD example running here. So this is RubyMine. It's an IDE. It's made by the same people that make PHP Storm, so it looks a lot the same, but it's not PHP. It's Ruby. So here you can see I've got my test cases, right? So I expect calculator result to equal 1, right? So I'm doing, let me see, this is divide test. So here's my add test, right? And the nice thing about having this in 2 languages, but it's the same app, it's still a calculator, is that I don't have to re-explain the calculator bit. It's just adding and subtracting numbers, right? So I've got return 0 when 0, 0 passed, right? And then I do calculator, add 0, 0, expect results to equal 0. And then over here is my actual application code. So here's my add method, right? Oh, you asked about running the test. So where do I actually run them is, for some reason I can't see it. Okay, I have it in here somewhere, I just can't find it. Yeah, so in this IDE, I can actually run my test from right here. So I might come in, refactor, change whatever I'm gonna do, and then I just click the run button and it just runs it. So it's super quick. I don't have PHP Storm set up to do that. That was part of the Docker weirdness I couldn't get out of earlier. I just kind of ran out of time. But you can set your IDE up to run test cases right there in your IDE. And I'm pretty sure, I don't do this because it annoys me, but you can have it to where anytime you save a file, it automatically runs your test. It's like a listener, basically. It's like, oh, that file changed, run the test. And so it almost, as soon as you hit save, it gives you almost instant feedback on whether that works. So that's helpful. The other time that I run the test, I'm going to jump back out of this, is bonus points time for continuous integration. So I'm running all of these tests locally on whatever machine is running my application. I like to use Docker, but you could run it locally with MAMP, you could run it on Vagrant, you can run it on whatever system you develop on, but I'm running it still based on my computer. I also generally set up a continuous integration provider on my GitHub repository that runs my test there as well. So I'm running it once, and then I run it again on GitHub. So that way I can't accept something if it breaks a test. And I can actually show you what that looks like really quick. So let's see. First of all, well, actually this is perfect. Let's see where we're at. telling me that I have nothing to commit, but I know that's not true. Should have lots of commit here. Oh, okay. 1 second. So on my GitHub repository, I have Travis set, and whenever I create a pull request, it runs all of my tests for me. Now, it's going to do a lot more than just run the test. Like, it looks at other things like coding standards. There's some security tests that I usually build into Travis. But the point being is that it's going to actually run those same unit tests again on this continuous integration provider. This is nice because, like, if I have other developers who are working on a project, they submit a pull request, it'll tell them immediately if something's wrong. I don't even have to review it. If the tests don't pass, I'm not even gonna look at it. They don't even bother, right? So this is nice because it gives you some extra level of test confidence that you run. And the other nice thing about using Travis that it's harder to do locally is I can test this using a matrix of different environments versus whatever I'm working with locally. So I usually use locally PHP 7.2 because that's what's on our hosting provider. It doesn't make sense to run in something that's not. But with Travis, I can say, like, hey, test this in PHP 7.1, test it in PHP 5.6, test it in PHP 8 if you want. Like, you can have this nice matrix of different things that it tests on. And so you can kind of get a sense for, hey, so that doesn't work in
What is
PHP
that?
7.1. Travis.
Travis? That's
Yeah.
just the name of the program?
It's called Travis CI, yeah. It's actually, so it's free for open source, I think. Don't hold me to that. It's like, you can start for free and then maybe they charge you a little bit. But there's a bunch of different continuous integration providers. I just use Travis because it comes with GitHub out of the box and I like it. Let me think what else. Okay, you guys want a bonus? All right, I'm gonna give you a bonus here. So we've talked a lot about test-driven development. What we haven't talked about at all is something I actually think is way cooler called behavior-driven development. And it's basically it's like step 2 to test-driven development. You kind of have to have test-driven development in order to do behavior-driven development. The difference between behavior-driven development and test-driven development is that in test-driven development, I'm testing that, like, the stuff actually works the way it's supposed to. Behavior-driven development tests that the application does what you tell it to do, right? So instead of testing the individual methods, you're testing, like, the whole application. And what makes behavior-driven development so cool is this language called Gherkin. It's called Gherkin, as in, like, the little sweet pickles. So Cucumber, if you haven't figured out that software developers are kind of nerdy, then you haven't been around enough of us for very long. So Cucumber is a Ruby project that started many years ago, I guess, and has now been adopted by a lot of other frameworks. So in PHP, they call it Behat, B-E-H-A-T. And what's neat about Behat and Cucumber is that they can interpret this Gherkin markup. And if you look at this, this isn't even code, right? It says, scenario, check if an odd number is odd. And this is actually not where you need to start. Let's go back to my add, right? Scenario, add 2 positive numbers. When I add 5 and 7, I should get 12. There's nothing about that you have to be a software engineer to understand. Agree? You asked about who writes the test. How do we write the test? It's one thing for me to go in and sit down with my IDE and have a business owner or a stakeholder write down tests with me. It's a lot easier for me to coach them on how to do this. Okay? If they can write this, then they can tell me exactly what they want the application to do. And then what's neat about the way that Gherkin works, or not Gherkin, sorry, Behat, or in this case Cucumber, is that it actually it'll actually generate test code for you based on that Gherkin code, right? So I'll even show you what that looks like.
I have a question for you.
Yeah, go ahead.
You said you get the client or something in there. Right? Is that how you communicate with them? Is that how they explain to you what exactly they want that
Bingo.
app or something to do?
Bingo. I sit down and write
And as
this
long
stuff.
as you can check each one of those, you're golden.
Yeah, if you can hand me a file, you hand me a file that has this in it, and I will make exactly that.
Okay.
And then what's nice about this is it's two-way accountability. It helps the communication. It definitely takes some time, right? Like, you can't just take a new client and expect them to do this.
Right, right.
Generally what it is we've got like, there'll be the stakeholder, product owner, and then there's either the product owner will help write these, or one of the developers will work with the product owner to basically like write out the test cases. And then once we get a handful of these, we're off to the races. We can start working on it. And usually they can't write it fast enough. I mean, it's the same as always, right? You're waiting on
Right.
the stakeholder to give you exactly what they want it to do. But the cool thing about this is it's version controlled, so everybody gets it, everybody who's on the project gets it. And again, living documentation. If somebody says, oh, well, it doesn't do this thing. Yeah, I know it doesn't.
Right.
It's not in the test. Put it in the spec, and we'll do it. But don't expect me to read your mind. We fired the mind reader from the team. Like we didn't have budget for the mind reader anymore, so we let them go. Right? So this is like step 2 a little bit of doing test-driven development. And there's some nuance behind this. Like you can't necessarily test everything in the same way that you can with TDD. So usually we'll do a combination of like a lot of behavior-driven development, but then with some still traditional TDD tests that you just can't explain the right way. But I could just as easily write this and turn it into test-driven to unit test, and then derive my test from that. But now it's like you've got to write the spec first, then you write the features to generate the test, then you write the application code, right? So it takes even longer to do it this way, right? I said it might take 3 times as long to do test-driven development. It might take 4 times longer to do behavior-driven development. But again, the product that is produced is 1,000 times better.
Your foundation is way more solid.
Yeah. And like, I don't know why this fascinates me so much. It shouldn't. It's actually relatively simple. But I just think it's nifty as crap to watch. So I'll show you how it works because it should blow you away. So let's go into my advanced calculator. Remember I told you about the derivatives? These are the tests that I wrote to explain a derivative. So I've got some tests for square roots. Let's do exponents, okay? Okay, so what's 5 to the third power? 15 times 5 would be 75, right?
Sounds good.
I might need somebody to check my, let's see. Okay, so I'm gonna run this test, and it's gonna take me a second. Again, sorry for switching context on you. I went from PHP to Ruby and didn't really tell you I was doing it. So if you're looking at this going, what is it? I'm sorry. The nice thing about Ruby, and honestly one of the reasons I love using Ruby in demos, even though we're talking about WordPress, it's not written in Ruby, is that this is pretty easy to understand. Like Ruby is really easy to read as a human. It was developed to be very human readable. So it works pretty well in demos where pseudocode isn't going to be enough. So it tells me that I have undefined steps, right? I just wrote this step, and you can see where I ran the test and it failed. Maybe you can see it. See this scenario when I check exponents of 5 and 3, I should get 75. It doesn't know what that is. So in order to do that, I have to actually generate the step definitions. Again, I like to let my IDE do the work if it will humor me. And I can say create step definition, tell it where to put it, okay? So then it actually takes that sentence that I wrote in English and it turns it into a test for me. And it basically, if you hate regular expressions, I'm sorry, because this is regular expressions all over the place, but it's basically saying, okay, I'm expecting this sentence that says when I check exponents of some number and some number, and then do this thing with it, right? So let's do art1 and argument 2. And when I run this now, I should be back to failed scenarios. Yeah, so 1 undefined still. So let's just find that really quick. Let's do this. Now when I run it, I have no non-existing, but I have 1 pending test, right? It's like, hey, this thing doesn't do anything yet, so you gotta make it do something. So let's do expect right? So I'm just basically telling this to, it's the same assertion I made before. I'm just telling it when I do this check exponents, call that calculator exponent function. Okay? And when I run this again, I should get a failed test because again, same as before, I don't have any sort of way of doing exponents in my application. There's no method to do it. So if I'm gonna get there, I've got to actually come into my my application, and I've got to make an exponent, right? Still failed. So let's see what happened. Oh, it says undefined exponents because I can't type. Still failed. because I can't tell you. Okay, so it says, so here's my test. It says, when I check exponents of 5 and 3, I should get 75. Expected 75, got 125.
That's what I was thinking, but I didn't want to say nothing. 5 times 25 is 25, and then 25 times 5, 5 to the third power.
Okay, so my test was bad.
I don't know.
Do the math for me. I
Yeah,
think you're right.
I went-
Yeah, 5 times 5 is 25.
And then 25 times 5 is 125.
Okay, so my test is just wrong. Right? Again, did I tell you that this would give you perfect code? No. If you write shitty test, you're going to shitty code. But actually it works already, right? If I just go back and correct the test, everything passes.
Nice.
Right? So I just refactored my application. I turned it into something that could do exponents. I wrote one test that describes what I wanted to do. I refactored my application to have one new method. All my existing tests are passing. I can call it a day now. I'm done. So I would commit that and move on.
Nice.
All right, so that's a little bit of a bonus for you.
That's a whole lot of testing
Wait, so
for
that's-
one little function.
That's gherkin and cucumber?
Yeah, so Gherkin is this code, the markup language.
Like the,
That's, just think of like, Gherkin is smaller than a cucumber,
gotcha,
so it's a little bit easier to eat, right?
okay,
This is a lot easier for me to go into a meeting with a non-technical person, which is usually the people that are my clients, and I can explain how this works to them and we can write this stuff together. Then I take that and I build the test cases around it, and then I write the application code. So yeah, the Gherkin is this part, and then the cucumber bit is this part. Right? Well, that's not even really cucumber, that's RSpec, but it's basically Ruby's testing framework, right? Let's see, what else? So we talked about continuous integrations, and then that's pretty much it. I mean, you know, I think I've given you enough that hopefully you get a sense for what this is. Hopefully you have enough information that you can go home and look this up on your own. You can do some research. You can try it out. There's a ton of really good examples. If you look me up on GitHub, I'm just rfair404, and I've got probably 5 or 6 different things on GitHub that use either test-driven development or behavior-driven development that you can look at. You can clone it, you can even fork it and mess around with it if you want. The code that I did in this demonstration, the WordPress stuff at least, is just called WPTDD. So if you look that up, it's on GitHub, it's open source, so you can play around with it. I will admit that it is not really ready to go because it took me a lot of work to get it to, I faked this demo, by the way. I cheated a lot to get this to work, so it might not work out of the box. But don't look at my stuff anyway. Go find somebody else's stuff because there's probably a lot better examples out there for that. There's some really good examples of coding katas on this codekata.com. It's simple stuff, right? It's like make a blackjack game that deals, 2 cards to each player. You pretty much already know what it takes to deal blackjack, maybe you don't, right? So you don't have to do a lot of critical thinking, you just gotta go figure out how to code it. So it's some good exercises like that, definitely a good place to learn. It's one of the things that I usually do with developers on my team when we don't have anything else to do. Like we finish all of the work that we're committed to early, and maybe we've got a couple extra hours or even a couple days until we start another cycle. Then, hey, we can just do code katas and like drink some beers and take it easy while we play around, and we're not doing production quality work, so who cares? There's a Code Wars website that you can actually, it's like a social competition where you can compete with other developers and do coding katas together, so that's pretty neat. And then I would also challenge you, if you're in WordPress land and you only do PHP or you only do JavaScript or maybe you only do the 2 of those, go find the Ruby codes. and go do the Ruby codes. A, you'll learn some Ruby. B, you'll really get a good sense of how test-driven development works. Ruby codes is actually designed to teach you how test-driven development works. It's designed to teach you Ruby, but teach you Ruby through testing. One of the differences between, if you talk to Ruby people who write Ruby software, versus PHP people, Ruby guys and gals are all about testing. So they are far more advanced than PHP people are, for the most part, when it comes to testing. I didn't talk about JavaScript's test framework. So PHP unit is what you run for PHP. There's a QUnit, which is a JavaScript testing framework. So you can write unit tests for JavaScript. There's a couple really good resources that are not in these slides because when I did this presentation originally, it had nothing to do with WordPress. But there's a tool from 10up called WP Mock, and it's pretty awesome. What it does is it actually mocks WordPress objects for you, right? So imagine you were writing a plugin that does something to the post content, right? Let's say you're writing a plugin that has a shortcode, just to give you an easy example. You can use WP Mock to make a post, put that shortcode in it, and then call like the content and test if your thing is doing what it's supposed to. So it actually allows you to mock WordPress stuff, right? Create posts, create users, create pages, create nav menus. You can do all sorts of good stuff with it that's actually relevant to WordPress. Because like obviously you're probably not going to be making calculators a lot with WordPress. Like if you do, you hopefully only have to do it once. So the examples that I gave weren't really WordPressy, but if you want to get into doing WordPress stuff, that's there. The WP CLI scaffold command will generate tests for you and give you some help getting started. It's a little bit out of date, it's a little bit clunky, so you may not find a lot of value in that, but I would definitely look at those as well if you're going to try and get into some TDD. And definitely get an IDE, so if you're doing this with Sublime Text or some other super hipster way of writing code, then like pay the money, get an IDE. I think PHP Storm, and I was a naysayer for a long time because I didn't need an IDE for what I was doing. Definitely a game changer and worth every penny, and probably the single best decision that a software developer can make is to buy an IDE that is specifically done for PHP, and with PHP Storm has great WordPress integration support out of the box. I'm not trying to knock any of the other IDEs out there. There's a ton of other good ones. I just don't use them because PHP Storm does everything I want it to do, and then some. Yeah, so that's it. Thanks, everybody.
Cool.
Thank you.
Any questions, thoughts?
No, that was good. Like I said, I was surprised how much testing goes into just a little thing like that. Yeah, you're not lying when it's 3 times as long.
Yeah, you have to take more time because you have to develop a much different mindset about how you're going to approach a problem. But what's actually interesting is that over time, the further down into the project you get, because like usually the pace of the project is, it gets really slow at the end.
Right.
When you get to the end, you've got this great library of tests. You can usually still keep moving just at the same pace. So overall, I think that it's less expensive to do this.
Right.
It's just that it's going to take you longer to get to like an MVP when you're doing this. The suggestion that I heard from somebody that I thought was really good was do this on a greenfield project. Like don't try to go back and take something that already exists and add tests to it, because you're basically going to rewrite the whole thing anyway, because chances are it's not testable in its current state. And in order to get it to a point of testable, you're going to break a lot of stuff along the way. There's an argument that you can, if you take something and you just start writing some tests for anything new, that's helpful, so that might be beneficial. But like I would do this on a project where somebody says, we've got nothing and we want this. Like if I'm starting from absolute scratch, try it there. That's where you're gonna get the least resistance for putting this into practice. And again, I would not suggest that you start out by doing this with like a client project where you say, hey, I've never done test-driven development before, but I'm gonna do it for you guys on your project that you probably want me to produce in some unrealistic time frame for some ridiculously low budget that, you know, I don't have time to go learn this. Like, do it on your own time. Do a coding kata. Like, go make a calculator. Do it using test-driven development. Go make a blackjack dealing thing using test-driven development. Like, take some reps before you get up to the plate and go try to hit John Smith's fastball.
Cool.
Cool. Thank you.
Suggestions
Yeah.
for learning PHP storing, because I was given a.
You know, vodka.
Well, I was the